Hi everyone, and welcome to my ENME 351 final project. What I've made is a motorcycle lean angle sensor. And essentially what this is it will show you the angle on which you are leaning when you're taking a turn on a motorcycle, which is important to know for performance and for safety. So first I'll start with the overall housing. I have all of my components contained within a box. On the outside, we have a couple of peripherals for the rider to see. On the left, we have a mini OLED screen, which will show the digital readout of your angle. On the right, we have a servo motor, which will turn left and right, which will show also the angle. Highlighted in yellow is a safe leaning angle, and in red is a dangerous one. Additionally, there's a red LED that will light up once the dangerous angle has been attained. On the side, we have a push rod, which when pressed will reset the Arduino. And on the back, we have some cutouts for the DC power supply and the USB. On the inside of the housing, we have a couple things going on. The top part is secured by 4 heat insert M3 screws, and also the Arduino is secured with 4 M2 screws, also with heat inserts on the bottom. I'm using the Arduino Uno and also an MPU 6050 3-axis accelerometer. This is all contained within the box where all the wires are held, and everything is connected together using a mini breadboard. We'll start off with the Arduino code. What's going on here is very basic. This just takes in the information that is sent from the MPU accelerometer and converts it to an angle, which is then listed in a CSV through the serial port, which the processing code can then read. There's not much interesting here besides taking note that when the LED turns on and off once the maximum angle of 45 degrees is achieved. And in our processing, there's not much interesting going on there either, but I'll show it anyways. I have a couple of pictures of the motorcycle at different degrees at 0, 15, 30, 45, 60, and 90 degrees, both in the left and the right direction, which will give a visual aid when it's connected to the processing code on the laptop. And this is the readout that the processing code gives us. We can see the y-axis, z-axis, and x-axis on the bottom. The x-axis is the main one that we're looking at because that's the lean from side to side, but the z-axis is also the forward and backwards, which is why I have a counter that counts the amount of hard braking, which is when 45 degrees tilting from front to back is achieved. Now also I have recorded the max lean angle. This is a feature that's seen on many high-end motorcycles. So now I'll show. When I take my device and I tilt it to the right, we can see on the screen, on the processing, it starts to reflect that also. We can see that the bike is leaning in the pictures, and it's also being reflected here. Now also, if I were to tilt this back 45 degrees, the red light turns on. That means that a hard braking event was recorded. And over here, my processing code, that's also recorded. The whole point of this device is to be mounted on a motorcycle. So additionally, I have this battery pack here which will power it when we actually put it on top, which I'll show later. The whole point of this device is to be used for telemetry and to give a little bit of feedback for a rider and how they want to know how much lean they achieved and how many times they broke hard. This will help for rider development and safety on the road. So here you can see we're now actually on the bike. I have it mounted in with a phone holder, and it's mounted at a net zero position-ish with a couple degrees of motion from side to side. And you can see as we tilt the bike to the side, we're gonna start getting our values. Left, right, about 15 degrees. And if we put it down on the kickstand, we're gonna get about 15 degrees, which is what the BMW service manual lists as the side angle when the bike is mounted on the kickstand. As you can see in the video before, the device does work and it functions well when it's unmounted and just stationary. However, one thing I did fail to account for was the vibrations that were actually being produced by the engine on the bike. The phone holder mounting it was not sufficient enough dampening for the accelerometer to actually register correctly at all times the tilt position of the sensor. It would often flicker the LED light as if it were going over 45 degrees. However, the device does work properly most of the time.